Hey everyone, let's quickly recap how we work with exponents when we have the same base, starting with multiplication. Here we have x squared times x to the third. Notice they have the same base of x. Now if we wanted to rewrite this, we could rewrite x squared as x times x, and we could rewrite this x cubed as x times x times x. And in total here we'd have 1, 2, 3, 4, 5 x's. So if we multiplied that out, our answer would be x to the fifth. And if you remember, the shortcut to this is whenever you multiply, all you need to do is add the exponents. All we have to do is add the exponents, and we would get 2 plus 3, which would also be x to the fifth. Looking at division, we could do the same thing. Here we have x to the eighth and divided by x to the third. So if we wanted to rewrite that, we'd have 8 x's here on top, 3, 4, 5, 6, 7, 8, and on the bottom here we'd have 3 different x's. So we'd have x cubed, 1, 2, 3. Now notice, since we're on top and bottom, the numerator and denominator, each one of these is going to divide out and we could cancel. So this one will cancel, this one will cancel, this one will cancel, and we'll be left with 1, 2, 3, 4, 5, or x to the fifth. Okay, can you guess or remember what the rule was when we divide exponents with the same base? You subtract, right? Because the ones in the bottom are all going to cancel out. So if we subtract it instead, here I'll go ahead and rewrite it down here, x to the eighth over x to the third. That would equal x to the 8 minus 3, or x to the fifth. Now whenever we have a power to a power, in this case x squared to the third power, notice this power to a power. If we wanted to rewrite this, we have x squared cubed. That would be x squared times x squared times x squared 3 times because we're cubing it. And remember, here we have our multiplication rule, which means add the exponents, and our answer to this would be x to the sixth. Okay, can you guess or remember what the power to a power rule was? Well, just like in this case, we rewrote this 3 times and added them all up, or you could just multiply your powers. So here we would have x to the 2 times 3, which would also give us x to the 6. So the shortcut for these is you multiply. Lastly, let's take a look when you have a negative exponent. Here we have x squared times y to the negative 2 all over z to the negative 3. And your rule when you have negative exponents is to flip them to the opposite side of the fraction bar. So now this x squared, we have a positive x squared, so that's going to stay the same here. So I'll leave that right on top. Now this y is to a negative power, negative 2, so we're going to move that to the bottom and make the exponent positive. Looking at this z to the negative 3, that's also a negative exponent, so we're going to move that up to the top and make that positive as well. So your rule when you have a negative exponent is to flip it to the opposite side of the fraction and change it to positive. Okay, brace yourself. We're going to do one super quick example. If you could do this nasty guy, you could pretty much do any problem I'm going to throw at you. So here we go. First, I'm going to start with this exponent here. Remember, our exponent rule is we multiply it by the other exponents. Now this 2 is really 2 to the 1. So here we're going to get 2 to the 1 times negative 4 is negative 4. A to the 2 times negative 4 is negative 8. B to the negative 3 times negative 4 is 12. All over C. Remember, that's like a 1. C to the 1 times negative 4 is C to the negative 4. D to the 5 times negative 4 is D to the negative 20. Times, we still have all of this over here. Next, I'm going to go ahead and get rid of my negatives. Here I have 2 to the negative 4. That's going to become a 2 to the 4 on the bottom. Here I have a to the negative 8. I'll put a to the positive 8 on the bottom. B to the 12 is going to stay on top. I have c to the negative 4 on the bottom. That's going to come to the top. And the d to the 20 is going to come to the top. Then over here I have no negatives, so we'll leave that the same. Next, we have to multiply everything out. So here we have b to the 12, b squared. So I'm going to add those. That's going to give me b to the 14. Here you have c to the 4 and c to the 8. So I'm going to add those as well. That's going to give me a c to the 12. Next, I still have my d to the 20. There is no d over here, so that's going to stay the same, d to the 20. Down here I have 2 to the 4th power, that's going to be 2, 4, 8, 16, so I'll put a 16 down there. And my a to the 8th, that's going to also stay by itself, so that stays the same. And we are golden. So if you remember your basic rules, multiplication, you add the exponents, division, you subtract the exponents, power to a power, you multiply the exponents, and when you have negative exponents, you flip it to the opposite side of the fraction and make it positive. It doesn't matter what order you go in or how big your problem is, just stick to those rules and you will eventually work your way down to simplified. You know you're simplified when you've only got one letter of the same base. Okay, it's been fun. Enjoy working with these and have a nice day.